Hi, welcome to the channel Too Irrational. I'm Pranay Sharma, and in this video we are going to discuss the solutions of CS1 paper A conducted by IFoA Institute in September 2023. We are going to go through the detailed explanation of each of the question, but if you want the answer sheet, I leave a number below where you should Telegram or WhatsApp your email ID and ask for the CS1 papers, and we'll get back to you as soon as possible. Do like, share and subscribe, and leave a comment, especially if you find any mistake, and I will leave a pinned comment with all any changes, any mistakes that we might observe later. Let's get started. Question number 1. Consider a random variable x with a discrete uniform distribution on the integer numbers 20 to 79. Determine the expected value of x. Determine the standard deviation of x. So we are going from 20 to 79 where 20 is included. So total number of values are 60. So probability for each value will be 1 by 60. And we want summation from 20 to 79 x into probability of x. So that is 1 by 60 summation x. Now for the summation x, I can directly take it from 0 to 79 minus 0 to 19. So that 20 is included in here. And the formula for that is just n into n plus 1 by 2. So this is what we are going to get. Similarly, for finding expected value of x square, I will split them into 2. And formula for that, going from 0 to n, we have n into n plus 1 into 2n plus 1 by 6. And accordingly, I got this much. So standard deviation was 17.318. Now, even if you don't know these formulas, you can find the summation x and summation x square values directly from your R programming. You could have said x, let's say it is a sequence from 20 to 79, and then you wanted sum x, and you can say it is 2970, or you could have directly calculated mean if you wanted, but that would not have worked. You could not directly just write from RStudio, so this will not work. But definitely finding the sum would definitely work, right? Similarly, if you want sum x raised to 2, you have 165010. These values you could have taken from RStudio, and you did not have to show this part, right? You could have directly written it, that 2970 by 60, and here directly 165010 by 60. Now let's go to question number 2. Question number 2. An analyst has modeled the loss in units of 1000 due to fire in a supermarket using a random variable x with the density function this, where a is a real number. Determine the value of a, and then second part is calculate the conditional probability that the fire loss exceeds 16,000 given that it exceeds 8,000. So first we will be using that total probability must be equal to 1 to find a. So we are going to say 0 to 20 integration f of x dx, that turns out to be minus 200a. We'll equate it to 1 to get a as minus 1 by 200. Then we'll just take the f of x because we want to find probabilities. So we have already done the integration. I'll just substitute value of x, and we get x into 40 minus x upon 400. I'll just substitute 8 and 16 here to get these as our probabilities. Now probability x greater than 16 given x greater than 8, we'll have a conditional probability where we get it is nothing but probability x greater than 16 upon probability x greater than 8. So the probability becomes 0.111. Let's go to question number 3. Question number 3. The probability mass function of a random variable y is defined by this. So clearly this seems to be a negative binomial distribution type 2, where k is a positive integer. State the distribution of the random variable y. Your answer should include an explanation of the meaning of the distribution's parameters. So we'll have y follows negative binomial k comma p type 2 distribution, where k is the number of successes, p is the probability of success, and y is the number of failures before kth success. Second is identify which one of the following option gives the natural parameter theta and the scale parameter phi and the relevant function b theta, a phi and c y theta for the exponential family for this distribution. So for part 2, we'll take this probability and we'll write it in terms of exp. So we'll have to take log for each one of those values, and we'll get exp y log 1 minus p plus k log p, and then this is just c part. This is going to be c. Then whatever is multiplied to y becomes a theta. Then because theta is in terms of p, then whatever is left becomes b theta. Okay. And a phi, because denominator is just 1, a phi is 1 as well as phi is 1, and this is c. So option A becomes our correct answer. Third part, derive using the properties of exponential family the mean of y. So b dash theta is going to be the mean of y. So first of all, p is 1 minus e raised to theta. We have just rearranged this, and now we have to convert our b theta in terms of theta. Then expected value of y will just be differentiation with respect to theta. So this is what we are going to get, and I'll substitute e raised to theta as 1 minus p. So this is our expected value, and we know for negative binomial type 2 that is going to be the expected value. Fourth part, identify which one of the following options gives the variance of y. So for variance, again we can use the exponential family. They did not ask you. Anyways, you don't have to show. This is an MCQ style question, so you just have to write one of the options. So I'll use the exponential family and figure out the variance. So calculated b double dash theta, that would be this, and a phi is already 1. So variance becomes k 1 minus p upon p square. Now again, you would not have to solve this because we know that negative binomial distribution, the variance is going to be k 1 minus p upon p square. Let's go to the next question. Question number 4. An insurance company collects and maintains a database of key policyholders data in relation to the business that they sell. First is list the properties that can lead to this data being classified as big data. Second is list 2 key issues related to the use of data that should be considered by this insurance company. So first, the properties for big data, we have size, speed, variety, and reliability. These are the 4 things that are going to classify any data into a big data. I've written a single line statement for each one of them. And for the second part, the insurance company should consider, first is any relevant professional guidance, that is technical actuarial standards, TAS, and second is any legal requirements. These are 2 things they should consider. Let's go to question number 5. Question number 5. X and Y are independent random variables. Let W and Z be the random variables defined as follows. Z is minimum of X and Y and W is maximum of X and Y. So let FW, XW, YW and ZW denote the cumulative distribution functions of W, X, Y, Z respectively. Identify which one of the following expression is correct for FWS. Now, when I write this question first, I quickly identified that A is going to be my answer because of the Z given here. So you can clearly see that the minimum is going to be X plus Y minus the maximum. So this is going to be our maximum. We can prove that very easily too. So although we have to just give the answer as options, but I will just show you how would we prove it. So we'll say f of w, that is probability w less than s, would be maximum xy less than s. That means x is less than s as well as y is less than s. Because they are independent, we'll get individual probabilities. That becomes f of x and f of y multiplied together. Now same way, if you want to go for the minimum, I will have to f of zs would be nothing but 1 minus probability z greater than. I am going to start with greater than because I'll say minimum value of x and y will be greater than s. If minimum value is greater, then both of these values will be greater. And because they are independent, I'll get multiplied probabilities. Then convert that into f of x as well as f of y. And open the brackets, you will find the value is going to be f of x plus f of y minus f of x into f of y. You did not have to show this, but this we did have to show. For the third part, random variable x has an exponential distribution with parameter 6 and y independently also has an exponential distribution with parameter 6. Identify which one of the following expression gives the cumulative distribution function of z. So you can just take f of x, f of y, f of x into f of y here, and you can easily find that. Or you can take this, I have taken from here because it will be easier. My f of x, f of y, I'll substitute and we are going to get 1 minus e raised to minus 12s. So the option is B. Again, you have to just give option. B part, state the distribution of and mean of z using your answer in part 3a. So by comparing the CDF and using the uniqueness property, we can say z follows an exponential distribution with the parameter as 12 and the mean is going to be nothing but 1 by 12, that is 0.0833. Let's go to the next question. Question number 6. A railway company investigates the impact of train delays on connection that passengers experience. In a survey, passengers are asked how many trains they use for their journey and whether they have experienced any delays. So they have given you the number of trains involved in a journey, then proportion of the journeys with X trains that are delayed in percentage and proportion of all journeys, that is 60%. So basically journeys involving only one train, there are 60% of them, 30% involve 2 trains and 10% involve 3 or more trains. And out of these 60%, 5% are delayed. Out of these 30%, 12% are delayed. Out of these 10%, 17% are delayed. Using the above summary data, calculate the probability that a randomly chosen journey involved fewer than 3 trains. So I have written the given data. I have taken A, B and C. It's just easier. Probability D given A, that is for delayed. Probability of D given B and probability D given C. Now we want total to be less than 3, involving less than 3. So it's just probability of A plus probability of B, that becomes 0.9. Second part, verify that the probability that a randomly chosen journey was delayed is 0.83. So we want probability of being delayed. We'll use the law of total probability for it. So the law of total probability, probability of A into probability of D given A plus B into D given B plus C into D given C, that would give me 8.3%. Third part, calculate the probability that a randomly chosen delayed journey involved fewer than 3 trains. Comment on your answer in part 1 and 3. So we basically want fewer than 3 trains, so I can calculate 1 minus probability that more than 3 trains given the journey was delayed. So using Bayes theorem, this is what we will get, and I am getting probability as 79.51. So 79.52%, let's say. So in the fourth part, we'll say from part 1, we observe that 90% of the journeys involve less than 3 trains, and from part 3 that they make up 79.52% of all delayed journeys. Hence, proportionately more journeys get delayed when more trains are involved in the journey. Or you can say they are positively correlated or something like that. The number of journeys and the amount of delays are positively correlated. Let's go to the next question. Question number 7. Total losses in a particular company are modeled by a random variable y with the density function this. An analyst wishes to estimate the unknown parameter c. Identify which one of the following expression gives the maximum likelihood estimator of parameter c. So again, we just have to write the option, but I'll show you how do we calculate it. So our likelihood is going to be multiplication of f of yi. So basically we are going to get c raised to n upon multiplication of yi's raised to c plus 1. When we take log likelihood, we'll get n log c minus c plus 1, and this multiplication will become summation of log y. Now differentiate, you get this, equating it to 0. Our c hat will become n upon summation of log yi. So the option is C. Second part, the analyst assumes a gamma prior distribution for C with the parameter a comma b. Determine the posterior distribution of C with all its parameters. So the prior comes from gamma distribution. So I have removed the constants. I just want the terms that contain C. Similarly, from likelihood, I would want only the terms that contain C. So here the c plus 1 will become the constant. So multiplication of yi raised to 1 is just constant, goes away. That is why I have just taken minus c here. Then posterior will just be multiplication of these two. Here I had e raised to, but here I do not have e raised to. So I will say whatever this term is, we know e raised to log of a is nothing but a. So a can be written as e raised to log of a. So that is what I have done here. So I have e raised to log of this pi yi raised to c. And as we have discussed here, when I take log of this, c will come out, and log of multiplication will just become summation of logs. So this is what we are going to get. And as most of the time our posterior is the same distribution as prior with the parameters n plus 1 and summation log yi plus b. Third part, comment on the relationship between the prior and the posterior distribution of C. And fourth part, determine the Bayesian estimate of parameter C under quadratic laws. So for the third part, we'll say we have a conjugate prior distribution. The prior and the posterior both have gamma distribution. In the fourth part, the Bayesian estimate of parameter C under the quadratic laws is going to be the expected value of our posterior distribution. So that is alpha by lambda. Now let's go to the next question. Question number 8. The time spent in minutes queuing in a line by customers in a bank is modeled by the random variable x with the density function this. The parameter theta is assumed to follow a priori. Clearly there is a spelling mistake. It should just be prior gamma distribution with the parameter a and b. First is identify which one of the following expressions is proportional to the posterior density of theta given a random sample x1 to xn of the observation from x. So first we will have to create likelihood from this as well as the prior from the gamma distribution. So prior, we are ignoring the constants, and for likelihood we'll get pi of theta e raised to minus theta x square by 2. So we'll have theta raised to n and then e raised to minus theta by 2 summation x square. Then we'll just multiply prior and likelihood to get the posterior, and clearly posterior has the same distribution as prior, that is going to be gamma distribution. I think that is what the second part is about. So we'll get gamma distribution with the parameter n plus a, and the other parameter would be summation x square by 2 plus b. The second part was state the posterior distribution of theta. For the third part, the waiting time of 10 customers are recorded in the table below, and the prior knowledge is determined with A and B. So basically they have given you the whole data, A and B is given, and all of the values of X is given. So you will need the values of X square. Okay, addition sum of X square, and total there are 10 values, and of course they have said 10 customers. So N is 10. Then the third part is calculate a point estimate of the time spent queuing in line using a Bayesian estimator under all or nothing loss. So for all or nothing loss, we need mode. So we'll say the Bayesian estimate under all or nothing loss is mode of the posterior distribution. Now I have shown here that for a gamma distribution, mode is going to be A minus 1 by B. I think even if you don't show this, that would be fine, but I would suggest at least state that for a gamma distribution, mode is going to be A minus 1 by B. I've just substituted that in the posterior gamma distribution. So I will have this, and the value comes out to be 0.91228. Let's go to the next question. Question number 9. The following 9 pairs of the data are given on the observation from two random variables x and y. Summary statistics of the data are shown below. So we have 9 pairs. So n would be 9. Perform a suitable statistical test to investigate the hypothesis that the Pearson's population correlation coefficient for x and y is positive at a significance level of 1%. So first I'll calculate the x bar, y bar, calculate sxx, syy and sxy. Then calculate the r value, that is 0.9931. So the test statistic for our hypothesis, that is rho equal to 0 versus rho greater than 0, we want positive, would be r under root of n minus 2 upon under root of 1 minus r square following t distribution with n minus 2 degree of freedom. So the statistic turns out to be 22.4028, and p value, I have used R programming to calculate this. You can use the tables. You'll just get a very small probability. So at 1% level, we have sufficient evidence to reject H0. Pearson's population correlation coefficient is positive. Second part, comment on the relationship between x and y based on your answer in part 1. So clearly it is positive and R is very high. So we can say there is a strong positive linear relationship between x and y. Third part, fit a simple linear regression model of y on x. And the last part, they are saying determine a 99% confidence interval for the predicted mean response where x is equals to 3. So first, for linear model, we'll calculate our beta hat, alpha hat as well, and we'll say yi will be equal to alpha hat plus beta hat xi plus errors. So we have our x naught as 3. So we'll calculate the mu naught hat. We just substitute it here. X is equals to 3 and we get 7.8633. We'll calculate the sigma hat square and accordingly calculate the variance of mean response. Then use that in the calculation of confidence interval. So 99% confidence interval, we'll have mu hat naught plus minus the t will have probability of 0.5% and the degree of freedom as 7, that is n minus 2 root of variance that we have calculated here. So this is what the confidence interval will be. Let's go to the last question. Question number 10. For a socioeconomic analysis, a random sample of 20 regions is considered. An analyst collects the data on average household income in units of 1000 denoted by X and the crime rate in percentage denoted by Y for each region in the sample. The data are displayed in the following plot and a summary statistics are given below. First is calculate a 95% confidence interval for the mean household income. So when we say mean household income, that is just X. So we want 95% confidence interval for X. So we calculate X bar and Sx square. So the 95% confidence interval for the mean household income is going to be X bar plus minus T 2.5%, comma, degree of freedom would be n minus 1, that is 19. Standard deviation upon root n. This becomes the confidence interval. Second part, calculate the Pearson's correlation coefficient for the relationship between the household income and the crime rate. The third part is justify why Pearson's correlation coefficient is appropriate in this context as compared to the alternative correlation coefficient measures. So the X bar, Y bar values, we'll calculate SXX, SYY, SXY. So we get our R value as minus 0.99555. So this is fine because we have negative relationship. We can see that from the graph as well. Now what about the justification? So we'll say Kendall and Spearman's rank correlation coefficient consider only the relative values of the bivariate data and not their actual values, hence gives approximate relationship. Whereas Pearson's correlation coefficient considers their actual values, hence gives more accurate relationship. As the actual values are available and the accurate relationship is desired, Pearson's correlation coefficient is appropriate. For the fourth part, for the three regions with the highest household income, the following data have been observed. So we have X value and Y value. So these are the three highest values. They are saying perform a statistical test to decide if there is a significant difference in the mean crime rate between the group of the region with an average household income more than 50,000 and the group of region with an average household income of less than 50,000. You can assume that the variance of the crime rates are the same in all region. Now, if you see the graph, you will see this is a 50,000 mark. So these are the last three values that they have given and these are the less than 50,000 values. Now we have to compare the mean of this crime rate for these three versus these ones. So first we'll have to bifurcate our data for the first 17 values and the last three values. So summation y for the first 17 values, I will subtract the last three values. Similarly, for y square, I will subtract the square of last three values. And accordingly, I will calculate the y bar 1 and S1 square. That would be this. Now for the last three values, I have the summation y as well as summation y square. I'll calculate the y bar 2 and S square 2 for that as well. Now assuming equal variance as the question says, I will calculate the pooled variance. Now we have to check whether mu's are equal or mu's are not equal. So we'll have to sample t-test. So the test statistic is going to be this, where degree of freedom would be n1 plus n2 minus 2. Statistics become this much. P-value, I have again used R programming to calculate p-value. It's very small. So at 1% level, we have significant evidence to reject H0. There is a significant difference in mean crime rate between the group of regions with an average household income of more than 50,000 and the group of regions with an average household income of less than 50,000. I've literally copied the last statement from the question. Last part, comment on the assumption of equal variance made in part 4th. Now, first of all, you can comment it by looking at the graph as well as looking at the values of S1 square and S2 square. So from graph also you can say that the variance here that are before the 50%, whereas here where it is greater than 50,000, and clearly see higher variance here versus here we have very small variance. So we'll say from the graph we can clearly observe that the points with x less than 50 has higher variance in y-axis as compared to points with x greater than 50. Same thing can be observed from the calculated standard deviations. Hence, equal variance assumption should be tested before testing the difference in mean. So that ends our paper here. Now, overall, the paper was very straightforward, easy, and was not very lengthy. So I am hoping that everybody got most of the questions right and would easily clear this paper. I am expecting that the passing mark will be high, maybe 57, 58, 59, something like that. I hope it does not cross 60 this time, because in April 2023 it did cross 60, it went to 62, but hopefully it will not be crossing 60 this time. If you find any mistake, do leave a comment below. I will reply as soon as possible. Do subscribe so that you get the notification for paper B video as well. I will be releasing the paper B video in 2 days, and I will see you in the next one.